Assalamu alaikum dear students. In this lecture we study integration. This is our topic. So this is lecture number 2. So uh, we know integral operator sign we also know we can apply integral operator only on functions. So how we can put function, this is our integral operator, okay? So we can apply function here, like here, and we cannot apply integral operator on equations. This equation must be function. So uh, now I want to teach you one by one this symbol. Like this symbol means like continuous sum. Whenever you see this symbol, you see you're adding and continuously. And this, for this symbol, is discrete. Actually, this symbol is used for discrete sum. Okay. So graphic representations. Okay, now I can show. Now I can differentiate these two symbols. Suppose this is y-axis, this is x-axis. So you have a curve and you want to integrate from A to B. You want to integrate this region. This is our close boundary. This is close boundary. So what does it mean close boundary? A or B also included in interval. So this is lower limit. This is upper limit. Okay. So now you want to integrate from A to B. Continuously, just you apply A to B, your function y dx, and you want to apply it discretely. You want discrete sum, so you have to make different sections here. So actually, this is I'm going to calculate the area. Discretely and makes different rectangles. You see here different rectangles, and then just I'm summing up these rectangles and then calculate total area of this curve. So we know area of rectangle. Area of rectangle is y. Suppose this is y, this is x. Y into x. Actually here, sine, y dx. Actually this is vertical, axis y, and this is dx. Why I write down dx? Because I make small sections. So this symbol, as well, d and capital D, both meaning has same, change. Okay, so now D, it means change, capital D means change. So what is the difference? Still there is a difference between small d and capital D. This is for, we use small d for small changes, and this is this symbol used for small and large changes. So small and large changes. So in calculus we have learned first principle, f of x is equal to f prime x equal to limit, x approaches to delta x approaches to 0 and delta y over delta x. So now the difference, f prime x means df over dx. So just if you if changes in x-axis is very small, and then it becomes like this derivative. So okay, now I'm going to teach some properties of integration. Okay, properties of integration. So first property is like if you have lower limit, upper limit, and this y dx. If you want to change the order of this limits, suppose now upper limit is now lower limit, and lower limit is now upper limit. So you have to add this negative sign here. Okay, this is the first property of integration. And second property is if the lower limit and upper limit same, then answer would be 0. Okay, and another property is like you have two functions f of x and g of x. First function is f of x, second function is g of x, and dx, right? Okay, we can write like this way: f of x, this dx, plus minus a into b g of x dx. If sign is positive, so like this. If sign is negative, so like this. Okay, this is a basic property. One another property is like if you have constant, if outside, yeah, if you have constant and which is multiplied with function, so we can put outside this constant value and we can write it this way. Okay, this is we have two types of integration. One is definite and this other is indefinite, definite or indefinite. This is definite integral because we have limits. If we don't have limit, like c f of x dx, this means we can write same, but we are not putting limits. So this is a indefinite integral, or this is a definite integrals. So thank you for watching. Bye bye.